You're welcome again to our physics online class. Now today we want to look at simple AC circuits. Simple AC circuits. Now what is the full meaning of the AC? Alternating current. Good. Now, we have two types of current. We have direct current. That is a current that does not reverse its direction when it flows. Okay, but we have another current that is known as alternating current. We know that direct current is that steady current that does not reverse its direction as it flows. But alternating current, that's the current that reverses its direction sinusoidally and periodically. So we can just take the definition. Alternating current is the one that reverses its direction sinusoidally and periodically. Okay, periodically. We know that for direct current, we have a graph like this, something like this, and then like this. It doesn't go down. Okay, and then also we can also have it in this form, direct current, and then it moves a little, and then like this, and then it moves a little, and then like this. Okay, it doesn't come down. Okay, this is I against T, and this is I against T. So this one is direct current, that is DC. Okay, but what is the graph? The graph of AC, look at it here. Okay, it reverses its direction. You can see it going up and down. Okay, we said sinusoidally because it's a sine curve. You can see sine curve. Okay, and it goes like that. Alternating is direction of flow. Alternating, that is changing its direction periodically. Okay, and that is alternating current, and that is AC. Now AC is represented, we have an equation we can use in representing alternating current. Now, so generally it's represented I is equal to I naught sine omega t. Okay, this is the general equation that represents alternating current. Now this I is known as the instantaneous current. Okay, and then this I naught is the maximum of the peak current, the maximum or peak current. Okay, and then omega, this omega here is the angular speed turning through. Okay, angular speed, and then t is time. But if we put omega t together, that is going to be phase angle. Okay, that is phase angle. So omega t together will give us the phase angle. Now, so we've seen the terms that make up the equation. Now we can also break that down. Look at it. I is equal to I naught sine 2 pi f t. Okay, 2 pi f t. I've removed the omega for 2 pi f because we know that omega is 2 pi f. Okay, so I remove the omega for 2 pi f. So it's only f now, and f is the frequency. Okay, frequency of the alternating current. Okay, now we also have a function for the alternating voltage. So what about periodic function for alternating voltage? Okay, for alternating voltage, similarly, it is V is equal to V naught sine omega t. So V is the instantaneous voltage. Instantaneous voltage just like the first one. V naught is the peak voltage. Okay, and then omega t is the phase angle, just as we have it in the other one. And then this omega is the angular speed. And we can still break it down. We can still write it like V naught sine 2 pi f t. So that is that. Now another thing we need to talk about is the root mean square. Root mean square value. The root mean square current. Okay, now how do we define that? Now this is the current, this is the current, this is the current, or we can say the steady current. This is the steady current, this is a steady current. And for writing steady current, you know that we are talking about a direct current. Okay, so root mean square current is the DC equivalent of what we have in AC, the DC equivalent of what we have in AC. So it is the steady current that produces the same quantity of heat in the same resistance, or resistor in the same resistance in the same time. So that is the definition of the root mean square value of current. And how do we write that? It is high RMS. Okay, that is root mean square value of the current is equal to I naught all over root 2. So that is the formula for finding the root mean square value of current. So the moment you know the value of I naught here, the moment you know the value of I naught, then you can take the I naught down here and then you find the root mean square value. So similarly, VRMS is the same thing as V naught all over root 2. So that is the relationship between the peak current and the root mean square value of current. Okay, now let's just look at some problems. Let's look at some soft problems, and then we can move to another are looking at soft examples. 1. An alternating current function is represented by V is equal to 220 sine omega, or let me use 5t sine 5t. The first question, find the peak voltage. What is a peak volt? The peak voltage. B, find the frequency. Find the frequency of the AC, of the alternating current. And C, find the root mean square value. Find the root mean square value of the voltage. And the last one, find the value of the voltage after 4 seconds. Now, so we have the AC function is represented by this. So the question was also to find the peak voltage, the frequency of the AC, the root mean square value of the voltage, and the value of the voltage after 4 seconds. So, solution. Now, we are going to compare the two equations. Okay, now the equation, the one we know is V is equal to V naught sine 2 pi f t. Okay, and then the function given us, let's write it on that so that we can make direct comparison. So this is 220 sine 5t. Now, the question says you should find the peak voltage. Now, what is the peak voltage? The peak voltage is V naught. You still remember that? Look at it here. The peak voltage, that is V naught. And then we have it here, that is V naught, that's the peak voltage. So definitely, peak voltage V naught is 220 volts. We can see it here. V naught is 220. V naught sine 2 pi ft, 220 sine this. And the second question says we should find the frequency of the AC. Now, if you look at it very well, it is after sine we have 2 pi f. Now, after sine we have 5, and then this is t, and this is t. So, which means it is 5 that stands for 2 pi f, and that is the f we want to find. Okay, so what we are going to do is equate 2 pi f to 5, and then we find the frequency. So let's do that. So we have 2 pi f is equal to 5, and then f is equal to 5 all over 2 pi. Okay, and we can leave the answer in that form. That is 5 over 2 pi hertz. Now let's go to C. The question said we should find the root mean square value of the voltage. Okay, that is talking about this, the root mean square value of the voltage. So we have V RMS, that is what the question wants us to find, and that is V naught all over square root of 2. So we are looking for this. So definitely our peak voltage, remember the peak voltage is 220. So that is going to be 220 divided by root 2. Okay, let me get my calculator. Divided by the square root of 2. Square root of 2. And that gives me 155. That gives me 155.56 volt. Now the next one says we should find the value of the voltage after 4 seconds. Find the value of the voltage after 4 seconds. So let's write the function. The function, find the value of the voltage after 4 seconds. That is talking about the instantaneous voltage. That is talking about instantaneous voltage. That is the voltage at an instant of time. That is, instantaneous voltage is the voltage of an AC circuit at an instant of time, at a particular point in time. Okay, so let's write the formula. So that is V, the periodic function, is equal to 220 sine 5t. But remember, the question says that t is equal to what? 4 seconds. The question says we should find the value of the voltage after 4 seconds. So which means our t is 4 seconds. So we are going to knock out this t and then we bring in the 4s. That's substitution. So V then is going to be 220, and that is sine, and that is 5 times 4. 5 and 4 together. Okay, 5 times 4. So this is 220 sine 20. Okay, 5 times 4. And let's get a calculator for that. So that is 220 sine 20. 220 sine 20. Now the answer is 200.85 volt. Now, for you to know whether you are wrong or not, or whether you are right or wrong, now look at it. There is no way your instantaneous voltage, okay, will be greater than the maximum voltage. Look at the peak volt, according to the question, is 220. So if your answer is greater than 220, then you should know that you are wrong. Okay, so that is a kind of check. Okay, now we want to go to types of circuits. Types of circuit. Okay, let's look at types of circuits. Okay, now there are certain components we use in an AC circuit. Okay, now you are familiar with direct current. Okay, that in direct current circuit you just use your resistors like this, and then when you use your resistors are used in regulating the flow of current. Okay, regulating the flow of current. But in AC circuits, we have components we use in controlling alternating current. Okay, we can use a resistor, and that is a resistive circuit. Okay, why? Because it contains a resistor. 2, we can also use a capacitive. We also have a capacitive circuit. Okay, a capacitive circuit. Why? Because there is a capacitor in the circuit, and also we have what is known as inductive circuit. Inductive circuit. Why? Because we have an inductor. Okay, an inductor. So these are circuits based on what they contain. Okay, we have resistor that would develop or give rise to a resistive circuit. We have we also have a capacitor. Right, a circuit can contain a capacitor, and that will give rise to a capacitive circuit. And then we have the inductor that will also be in a circuit, and then it will give rise to inductive circuits. You know, in a circuit, voltage and current move in a way. Okay, voltage and current move in a way. Voltage and current move in a way. So we want to see the relationship between the motion or the movement or the flow or the phase between voltage and current. Now, in resistive circuit, now voltage and current, okay, are in phase. Okay, what does that mean? It means they attain their maximum, minimum, and mean values at the same time. They move together. Okay, they move together. So they are in phase. They move together. One does not lead and the other one following. Okay, one does not lead and then we have the other one. So the two of them, they move together, and that is the meaning of they are in phase. Okay, they get to the maximum point, get to the minimum point at the same time. Okay, so no lag or lead, no lag or lead. The two of them, they move together. Now, what about capacitive circuit? Okay, capacitive circuit. Now, in a capacitive circuit, current leads. Okay, current leads while voltage lags. Okay, now current leads by a phase angle of 90 degrees. Current leads. So when you want to write the current function, is going to be I is equal to I naught sine omega t plus phi. Okay, so where phi is the value is pi over 2, and that is 90 degrees. Okay, now the voltage, the function of the voltage is still V naught sine omega t. Okay, so for resistive circuit, V is equal to V naught sine omega t, and I is equal to I naught sine omega t. Okay, that is for resistive circuit. So you can see now that for resistive circuit, the two of them, they move at the same time. So there is nothing like plus. We don't have any phase difference. Okay, but in a capacitive circuit, current leads while voltage lags. Okay, now what happens in an inductive circuit? So in an inductive circuit, now current lags and voltage leads. Current lags and voltage leads. So how do we write their functions? Okay, now in an inductive circuit, V is V naught sine omega t, but I, current, we are going to say the lag now, I naught sine omega t minus phi. Okay, and then we know that that phi is pi over 2, 90 degrees. So current lags by 90 degrees. In a capacitive circuit, current leads by the same 90 degrees. But in a resistive circuit, there is no lag or lead. Okay, good. Now, the next thing we are going to talk about now is the opposition that is offered components, okay, resistor, capacitor, and inductor. Okay, when they are used in an AC circuit, then they offer an opposition to the flow of current. So that is the next thing we are looking at. Now I want to look at opposition to flow of AC. All right. Now, but before we do that, let's just sketch and see what an AC circuit looks like. So you can see these are resistor, these are capacitor, and these are inductor. You can see an inductor is a coil. You can see that. Okay, and they are connected in series. So we talk about an RLC or RCL series connection. They are connected in series. So the moment we know the current that is flowing, the same current goes through them. So when the current gets here, the V that will be developed is VR, okay, and that is IR. When the current gets here, we are going to have VC, which is I, XC. We are going to talk about the XC, that is where the opposition is coming from. And then this one also is VL is equal to IXL. Now, so you've seen that we have XC and XL. They are the opposition to the flow of AC. And since we know that this one is resistance, the opposition to the flow of current offered by a resistor is resistance. Okay, the opposition to the flow of current that is offered by a resistor is termed resistance. Now, the opposition that is offered by a capacitor to the flow of current is known as the capacitive reactance. Okay, so this XC you are looking at, okay, is known as the capacitive reactance. Now, the XL is also inductive reactance. So reactance now, can we take a definition for reactance? So reactance reactance is the opposition to the flow of alternating current that is offered by either a capacitor or an inductor. Okay, so and the unit is ohms. The unit is ohms. So the unit of either capacitive reactance or inductive reactance is ohms. Okay, so this one, capacitive, it has its own reactance. This one also has its own reactance, and this one has its own resistance. So when we put the three together, we talk about the impedance. Okay, when the opposition coming from the three, the overall opposition coming from the three, as we have it here now, is known as impedance. Okay, so in some circuits we could just have maybe a resistor and a capacitor. In some we could have a resistor or an inductor. Okay, it is not really necessary for us to have the three. Okay, so but the overall opposition that is offered by two or the three of them is known as impedance, and that is the last thing we are going to look at today. So let's talk about impedance. Now impedance is the overall opposition to the flow of AC, to the flow of alternating current, to the flow of alternating current, to the flow of alternating current that is offered by two or three of or you can use two or all, because three of them, two or three or two or all of resistor, capacitor, and inductor. Okay, now its symbol is Z, and unit is also ohms. The unit is also ohms. All right, so in our next class we are going to see how we derive formulae for some quantities like the impedance. We need to draw the vector diagram, and then even for VR, VC, VM, we need to see the relationship between the quantities, and then with that we build our formulae, and then in our next class we are going to apply our formulae. Now in the PDF section of your lesson, you go to the PDF section. That is where you are going to see your questions. Okay, I'm not going to write your questions here, but go to the PDF section of your lesson, download the PDF, and answer the questions. Until I come your way next time, stay safe.